Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. So let us first read this question, then about constraint, examples, and then finally the coding part for this scene. So here it is given arithmetic slices to subsequence. So given an integer array nums, return the number of arithmetic subsequences of nums. A sequence of number is called arithmetic if it consists of at least three elements and the difference between any two consecutive elements is same. For example, 13579 4 times 7 and 3 minus 1 minus 5 minus 1 are all arithmetic sequences because we can clearly see difference between these is same, means 3 minus 1 is 2, 5 minus 3 is 2, and if we see 7 minus 7 1 0, 7 minus 7 0, right? And if we check for this, uh 3 minus 1 is 4, then minus 5 minus plus it would be 4, and it goes on. So for example, this one 112579, here it is not an arithmetic sequence, means this whole, because here we can see difference is 0, here difference is 1, here difference is 3, and here difference is 2. So everyone is having a different difference. So that's why it is not arithmetic sequence. A subsequence is any array in sequence that can be formed by removing some element, possibly none of the array. And for example, 2 5 10 is a subsequence of this 1 2 1 2 4 1 5 10. So the test cases are generated so that answer fits in 32 bits. So that is the thing. Here we can see that nums.length is basically less than equals to 1000, means at max 1000 elements would be there. And as they mentioned that test cases are generated so that it fits 32 bits. So that's why like nums of I could be at max this much and at minimum this much. So now in this first example, if we can see, here the output is 7 and how it is. Here you can see that 2 4 6 which is there. This is one subsequence. Then 4 6 8 is another. Then 6 8 10 is another. And this whole is also a subsequence because each and every element which is there having same differences, means each pairs which would be there in this particular subsequence. Now if we take about this one, here also it's the same. And if we take about this one, this is also same. And if we take 2 6 and 10, right? So in that also the difference would be same. So like that, this was now explanation of the question. Now comes the part that how we will be doing this question. The thing is that here we are required to check all the subsequence which are arithmetic, means basically we are figuring out with all the pairs which we could combine and get one subsequence which we can call as arithmetic subsequence. And like that only we need to figure out those number of subsequences which could be formed. Even if this whole array is a arithmetic, right? In that also there are some chunks, minimum 3, which could be a subsequence, as you can clearly see. The whole is also completely arithmetic sequence, but in that there were 3 subsequences, although these are sub arrays. There were 3 subsequences which were in arithmetic form, right? So in total then count becomes 4. And when we increase that 3 to 4, then in that context also this becomes arithmetic subsequence. And now these were all low sub arrays because they were consecutive in nature. But if we check for this 2, this 6, and this 10, now this we can clearly see as a subsequence, and the difference between them is same, and that's why this we can say that this is that seventh one which is a subsequence and it is arithmetic in nature. Now like that we are required to figure out all the possibilities which could be there. So as per the constraints which are mentioned, right, the constraint are in that manner that we can easily go ahead with a DP solution. So when it comes for the part of DP, now today in this video I won't be showing you anything about recursive or memoized DP. I will be showing you for the iterative DP. So in the iterative DP we know that there is transition and state. Now comes the part that what state would be there and how we will be going ahead with the transition part. So for that we need to go ahead with some things. I'll show you. So here's that part. Now basically we will be taking FID, which will be denoting the number of arithmetic subsequences where A of I, basically this Fi of D will end with A of I and its common difference would be D. Basically here I, this simply represent that this is from the A of I, basically the last element of that subsequence, and the D which is there, that will be the common difference of all the elements till now in that subsequence. So this is what we will be taking our state in the DP. And how we come up with the state is because we require a particular subsequence, right? And in this we are required with difference also, and the number of elements till now, basically the indices are also important here because we require that minimum there should be 3 elements, then only it would be a valid arithmetic subsequence. So that's why here we require with the index, and for arithmetic subsequence we require common difference as well. So that's why here we require the D. So that's why a state is having I and D both variables. So this will be acting as our state. Now comes the part for the transition. So here this is for the state and now this is for the transition. So for the transition part, what we are required to do is we will be taking two variables j and I, and we will be checking this you already know that this is the last element of that subsequence, and this is how we are checking for the two elements and its difference till now, means that I last element and j any element before this I, and then we will be basically adding up the same difference which is there, and this is that element just before that I, where A of j is the last element of that subsequence. We will be adding the count of that to this, and this is how we will be transitioning. Basically this will help us to count valid number of arithmetic subsequence, that is minimum 3 are there or not, and more than that are also possible, as already I have shown in that example that 2 4 1 minute, that 2 4 6 8 10. Here the minimum is this one, but at max it can go till 10 because all of them have same difference, right? So that's why here when we are adding them up in that, so it is playing the same role only. Now the part is that we can't directly go ahead with this type of transition, so we will be going ahead with weak arithmetic subsequences, and for that the transition would be something like this, means we will be adding a 1 because the point is that we are checking the difference between two elements, and at the first we will be storing that only, but that is not, as per the question, that is not just not a valid arithmetic subsequence. So in context to that we will be taking smaller portion, means rather than taking a 3 we will be taking two elements and we will be storing its difference. That is how we are doing here, and then adding 1 to it, and because of that this would be stored with us. But the point would be when some third element comes which basically have the same difference with the last number, then we will be simply adding that up, and then only it will be making our arithmetic subsequence, basically the strong arithmetic subsequence which is being asked in a question. So like this this would be the state and this would be the transition. And for making both of the state and transition in action, now we are required to take the data structure accordingly. So for this purpose, what we will be doing is we will be taking one vector, and in that we will be taking one map. So basically here we will be storing our a of I, and here we will be storing our difference. So why we are taking map inside the same? Just for the fact so that we can do easy lookup into the same, if that already exists or not. If that would be existing, then in that context only we will be adding whatever sum which would be there, means this sum which we are taking, whatever sum would be there, we will be adding to our final answer if that exists in this particular. And if it doesn't exist in this particular, then we won't be adding that, then the sum at that point would be zero only. And that sum is basically the number of elements, that is the thing which I am saying about the sum. So that would be the whole thing here. Now let us go ahead with the coding part for the same. So basically here, first we are taking whatever vector which is given to us, right? And then this is the one which I told, this type of data structure we are using. Here this LL represent the A of I, the element till now, and here it represent the difference. Basically this is what our state is. And now we are basically taking two loops to get our all the possibilities, because just for doing the transition before that, as this is a DB question, so surely we would be having many possibilities. And for checking all those possibilities, we are using these two basically we are using this one nested loop. And as I told, that state simply represent A of I, the last element till now. So in that context only, I'm taking this loop also. Now here I starts from 1 and it goes till n, right? But this j which is there, it goes till I, which is representing the last element of that subsequence. So that's how we are taking these two for loops. Now here we are calculating the difference of those two elements. Means basically whatever ith element, here we can clearly see I is at 1 and j will be starting from 0, so j is at 0, so here j is there and here I is there, right? So what we are doing is we are taking its difference, right? So whatever at 1, means if we take this example only, 4 minus 2, means this was for I and this was for j, so these element and difference is 2, so here delta would be stored as 2. And now every time in this for loop only, first we will be taking sum as 0 only, because we don't know that is the because we don't know that does that pair whose difference is this much, is there any other pair which existed before whose difference was this much or not. So in that context we will be going ahead. Now in that map vector of map which is there, so in that we will search that does that delta already exist, means basically does that difference which we calculated just now, does that exist. If that existed, then whatever number of element was being stored at that point, so we will be directly assigning that to sum if that existed. And if that doesn't existed, right, so it will never enter this loop, never enter this if condition. And in that context, then at this present moment, means basically at this particular state, what we will be doing is our sum would be 0, right? But we got a new delta, right, with a new pair, so we will be adding 1 and just we will be simply assigning that value to our this count. That would be the case. And if it was already found in that if condition, Re- hmm. and if it was already found in this if condition, right? So whatever sum, see if it was means here it is starting from 1, right? If it crossed 2, means if I is at this point, right, and j is at this point, right, and now we have 6 minus 4, so this is 2, and this difference was already there in our count, right? Say means in next step it was already there, right? So then in that condition, earlier sum would be 1 because here the value would be 1, right? And one new pair we have added, so that will be also 1, right? So now in that context, we will be adding that, but here the sum will be adding up as 1 only because the sum value was 1. And how it got that? Because we figured out with a valid subsequence, means this one. So that's why, and this is counted as a because we require minimum 3 elements for a valid arithmetic sequence. So that's why this will be counted as 1, and that sum would be added to this answer. And like this only, it will be checking for all the possibilities, and at the end we will be returning our answer. So this was all for this particular solution. Now comes the part about the time complexity and space complexity. So we can clearly see that here time complexity is order of n square, right? Because this can at max go till order of n, right? And this thing also, when I here is 1, right, but I will reach somehow at n minus 1 also, right? So j less than I. So at that condition, this loop will also be till order of n. And apart from all of these, we are not using any other loop. So that's why the time complexity here will become order of n square, right? Now comes the part for the space complexity. So here we can clearly see that we are just using our one vector of map, basically the data structure which we created for referring our state. So here you can clearly see that how elements are being stored in this. So basically it is a 2D one, right? So here till n, and here also at max till n would be stored. So here the space complexity also becomes order of n square. So this was all for this particular question. If you have any doubt, you can comment that down. And if you have any other solution, that also you can comment down. So this was all for this. And if you really like the solution, do like, subscribe, and share this among your friends. So this was all. Thank you.